One of the fun things about mathematics is the way that sometimes things that appear to be unrelated are actually connected in unexpected and interesting ways. Today we're going to look at connecting binomial multiplication and the Pythagorean theorem. So to start off with, I'm going to draw a 7 by 7 square. And then inside that square, I'm going to be drawing two smaller squares. So I'm going to do a 4 by 4 in one corner. And then right below that, on the bottom right corner, I'm going to put a 3 by 3, like this. And the space that remains is a sort of stunted L shape. I'm going to divide that into two rectangles that are equal in size. So this is how I've divided up my space. So I've got some dimensions to add on here. 3 by 4. And around the side like this. All right, so based on this sketch that I've got here, I've just shown visually that 3 and 4, which is 7, squared, literally in the shape of a square, is going to be equal to 4 squared, that's shape A, we'll say, plus 3 squared, that's shape B, plus 2 of these rectangles. The rectangle's dimensions are 3 by 4. Okay, and if you've forgotten how to find the area of a rectangle, just as a reminder, the area is length times width, or base times height, if you like. So I've got base times height here, and then times 2 because I had 2 of them. So first thing I want to do is connect this with binomial multiplication. So I'm going to draw that again. 3 by 4. But instead of putting 3's and 4's, I'm going to put A's and B's. And which value is the A or the B? Doesn't really matter. I'm going to choose the 3 is the A. Like that. This is also an A here and here. And then the 4 is I'm going to call B. Okay. So the area of this whole shape is going to be B times B. That's B squared. A times A. And then 2 of these rectangles. Well, the area of the rectangle is A times B. That dot can represent a multiplication. So the convention in mathematics when you are dealing with variables or polynomials that have more than one variable in them is to put them in alphabetical order and descending order of the exponents. So I'm actually going to put the A squared term first because A comes first in the alphabet, and then the B squared, and then the 2AB. If I want to be making it resemble something that maybe you recognize. I'm actually going to shuffle that b squared down to the end. So what I've just shown here is that a squared plus 2ab plus b squared is the square of a plus b. So that's binomial multiplication, actually the square of a binomial. Now we're going to see how that relates to Pythagorean theorem in an interesting and unexpected way. So keep that up there. So this time I'm still going to start with a square that is the same width and the same height as my original, so 7 by 7. Okay. But this time, instead of using rectangles of a times b, I'm actually going to divide those rectangles into triangles. So here's what I mean by that. I'm going to add a little diagonal in here. So I'll go this direction. And I'm going to add another one in here. So each of those rectangles has now been divided into a triangle that still has 3 by 4 as its dimensions. Okay, and these are right angle triangles. So I'm going to take those 4 triangles that you see here, 1, 2, 3, 4, and instead of having them arranged in an L shape, I'm going to arrange them around the outside of this square. So I'm going to start with 4 by 3 on this corner over here, and then 4 by 3. 4 by 3. And what you'll see in the inside is a little right triangle, or sorry, a square that appears in the middle as a result of rotating those 3 by 4 triangles around the outside. Okay. So looking at the dimensions of this entire pink square here, it's 7 by 7. So 7 squared would represent the area of that entire pink square. If I wanted to find the area of the purple square that's inside there, I would need to take away each of these little triangles from that 7 squared. So I'm going to do that. I'm going to say take away 4 triangles equals, I'm actually going to turn it back to purple here, so 1 little purple square. Okay, so 7 by 7, that's 49. Area of a triangle is base times height divided by 2, so I've got 3 by 4 divided by 2 equals that little purple square. I can drop the 1, it's not doing anything for me at the moment. So that's still 49. Okay, over here I've got 12 divided by 2 is 6. So 4 groups of 6. Four groups of 6 is 24. And the result of that subtraction is going to be the area of that purple, which it turns out is 25. And given what we've seen previously about the connection between the area of a square and the dimensions of the side of the square, I can say that the side length we'll call that C right here, is going to be the square root of that 25, which is 5. So we just did two things. We've used the area of a square and then dividing it into triangles and squares to prove binomial multiplication. We've also figured out something else interesting. We figured out that a squared plus b squared plus 2ab which was the area expression based on the diagram at the top, is the same as c squared plus 2ab's So if you look really closely at this, where we're at right now, on the left-hand side of this equality or this equation, I have 2ab, and I've got 2ab on the right-hand side of this equality. And if you're wondering where that came from, this 2ab, that was 4 times the ab over 2. It simplifies down to 2ab. Okay, so because I've got these two ab on the left and the right, they're equivalent. I could remove them both, one from the left, one from the right, each of those terms, and it would still remain balanced. The result of that subtraction is the Pythagorean theorem.